Let's talk about using function notation and how to find the domain and range of an equation, both from a graph and from the equation itself. What is function notation and why do we need it? Well, function notation is basically an alternative way of indicating the dependent value or the y value. This actually requires 4 characters to type out. We've got f, open parentheses, x, close parentheses. We read this as f of x. It means the function value of x, or the value of function f. So f represents the name of the function at x. So if we write something like f of x equals 3x plus 2, that means exactly the same thing as y equals 3x plus 2. In this notation that we're used to, we have the x value as the independent value. We choose it, we plug it in, multiply by 3, add 2, we get the y value. So we have a point x, y. Here, we choose a value for x. We can write it here and here. On this side, we're going to have to take it, multiply by 3, and add 2. And then we have the function value at that x value equals the y value. For instance, over here, if I let x be 2, then the y value is going to be 3 times 2 is 6, plus 2 more is 8. Here, I can specify what I'm plugging in by saying f of 2. I replace the x with the 2, equals 3 times 2 plus 2. So f of 2 equals 8. Now notice when I get down to here, there's no way to recreate what the function was, but I can't do it from over here either. So this means that when x is 2, the y value is 8. It still means this function contains the point 2, 8. One super advantage about function notation is that I can have multiple functions. I can say f of x equals 1/2 x plus 3. And I can't call them all f in the same problem, but I put g of x equals x plus 2 over x minus 5. H of x equals the square root of x minus 3. And if I say find g of 2, this, just this, is all it takes to tell you which function to go to and what to put in place of the x. So g of 2 would use this one, so we know it's going to be 2 plus 2 over 2 minus 5, so 4 over negative 3. And then I could say find h of 6. Tells me to go to this function. So h of 6 would be the square root of 6 minus 3. So it'd be the square root of 3. So this particular function I know would have the point 6 square root of 3. Now, there's two things that will restrict the domain of a function, because there's two things we can't do. We cannot ever, 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 ever divide by 0. We cannot have 0 in the bottom of a fraction, and it doesn't make any sense. You know that 6 over 3 is 2, because 2 times 3 is 6. We even know that 0 over 3 is 0, because this 0 times 3 would equal 0. But what about 3 over 0? 3 over 0 equals what? Well, no problem. You just have to figure out what times 0 equals 3. See the problem? Nothing times 0 is going to equal 3. This is undefined. You cannot include any x value that would make your y value not a real number. This is not going to be defined. So the domain is assumed to be, when we have an equation, anything that you're able to plug in place of the x and get a real number as a result. There is nothing that you can't multiply by 1/2 and add 3. So the domain here is all real numbers, negative infinity to infinity. Here we have a problem. Let me clear some space here. In this function, we cannot keep any x value that would make the denominator 0. We can't have a 0 in the denominator. So what would make the denominator equal 0? Well, if I set the denominator equal to 0, then I'm quickly going to realize that 5 is the problem. So the domain here is that x cannot equal 5, because that would make it undefined. The way to show on a graph everything except 5, this is my 5, would be everything over here, parentheses to show it's not included, everything above 5, parentheses to show it's not included. This is everything except the number 5. This means everything except the number 5. I can put it in set notation by just putting these 4 characters around it. Open brace. This means x such that, so this part says what the variable is. The x's, the set of x's such that x is not equal to 5. I can add, if I so desire, that x is an element of the set of real numbers. Technically, that's a good idea. So add all of this, just put it around here. So this is called the set notation. This is the graph. This is just a single value, so I don't need 2 lines. This is just a graph on a number line. And then we have interval notation. Interval notation is a way of writing this without putting the line itself in. We know I've got negative infinity at the top or at the bottom, and positive infinity, well, negative infinity on the left, positive infinity on the right. So this is 2 different intervals. One goes from negative infinity to 5 with a parenthesis to show the 5 is not included. One is on the other side, parentheses 5 to infinity. And then we put a union. The U sign is for the union. It means the 2 of these together make up the whole answer. So this is the domain for this, would be from negative infinity to 5, parentheses, union 5 to infinity. Remember that the bracket includes that number, and the whole point here is we want to not include that number. Now, again, let me make some space. The other problem we run into in functions is that you cannot take a square root of a negative or any kind of an even root. Can't take a square root, a fourth root, a sixth root. Cube root's fine. Fifth root's fine of a negative. But here we cannot take the square root of x minus 3 unless x minus 3 gives us either a positive number or 0 itself, which is not considered either positive or negative. So whereas with the fraction, we just found out what that one value or two, maybe three values that we couldn't use was. If it was a quadratic, an x squared would get 2 answers probably. X cubed would give us 3 answers possibly. But here, this is split between the numbers that make x minus 3 smaller than 0 and the numbers that make it 0 or larger. So we might as well go ahead and find out what it is we can use. We can use anything as long as it makes x minus 3, whatever's inside the radical, either greater than or equal to 0. Greater than 0 is algebra for positive numbers. If I solve this, just linear equation here, or a linear inequality, this is going to be x is greater than or equal to 3. So the set notation would be the set of all x's such that x is greater than or equal to 3. The graph would be the numbers that are greater than 3. And in this case, it includes the 3. So we would put a bracket. The only difference between the parentheses and the bracket in interval notation is the bracket includes that. And here, the whole point was to not include the 5. Now the interval notation, we got nothing below 3. But it goes up to positive infinity. So the interval notation would be from 3 to infinity. Now you can't just assume it's going to be the numbers above this. What if I had f of x equals the square root of 5 minus 2x? If I set 5 minus 2x greater than or equal to 0, then I'm going to subtract the 5. Negative 2x is greater than or equal to negative 5. But when I divide by a negative 2, I have to turn this around. So it turns out to be x is less than or equal to 2 negatives will make this a positive 5 halves. So now notice I'm not finding any kind of function values. I'm not getting y values. I'm only looking at the x values that I can use to figure out, first of all, what can I plug in? So my set notation is just the set of all x's such that x is less than or equal to 5 halves. My graph, that's positive 5 halves, less than would be over here, less than or equal to would put a bracket on that. And so my interval notation, since this one goes to the left, is going to be parenthesis negative infinity to 5 halves with a bracket. always, always, always use a parenthesis with a negative infinity or a positive infinity. Never, never put a bracket on those. Make sure in your interval notation, you always put the small value first and then the large value. So negative infinity, if it's in there, it has to be the smallest value. So negative infinity can only go on the left with a parenthesis. Positive infinity could only go on the right because there can't be anything larger than that. And it would always have a parenthesis. So it's real easy. Frequently, we're going to be mixing parentheses and brackets in the same problem. So that's how you find your domain from an equation. Next, we're going to talk about how to find the domain and the range from a graph. And while it's pretty easy to find the domain from the equation, it's much, much easier to find the range from the graph. So we're not really going to talk about how to go about finding the range from the equation here. So on to the next video. Have fun. See you later.